Welcome back, students. In this section we are considering the refraction of light through a prism and the dispersion of white light. What is meant by a prism? Prism is a transparent medium made up of glass. Normally it consists of 3 rectangular lateral sides and 2 triangular base sides. These 3 lateral sides are inclined to each other by making an angle 60 degree normally, and that angle is known as the angle of prism. 3 of these rectangular lateral sides are inclined each other with an angle 60 degree. That is known as the angle of the prism. Next we have to consider what happens when a light ray is passing through this kind of a glass prism. What happens when when a beam of light or a single light ray is moving from air to this kind of a glass prism? What happens to that light ray? Surely that undergoes refraction, that we all know, because when light moving from one type of transparent medium to another type of transparent medium, its path undergoes a change or path undergoes a variation, and that phenomenon is known as refraction. Surely this light ray is also undergoing a refraction. Then after refraction, what will be the path of that refracted light ray, or what in a general situation what happens to that path of that light ray? That we have to verify. With the help of an activity we can verify that one. Almost a similar activity which we have conducted in case of a rectangular glass slab. Here we have to consider a glass prism. Then first we have to trace the outline of that glass prism, then considering an incident light ray to the one side of this glass prism. So in order to consider that incident light ray, first we have to select one lateral side and just drawing a normal line at that particular side. Then consider a particular oblique angle of incidence and draw a incident light ray. In order to represent that incident light ray, we have to place 2 pins. In order to represent the considered incident light ray, we have to place 2 pins. Then after placing that pin, place the prism in that particular corresponding to that outline. Then observing through the other side of the prism near to the base side, observing through the other side which is near to the base of that prism, we have to place another 2 pins in a way that all the 4 pins lies in the same line. While observing through the other side, we can see that all the 4 pins are lies in the same line. In such a way, we have to place another 2 pins on the other side. After placing that 2 pin, just remove the prism, then remove the pins and join the dots obtained by placing the other 2 pins. And after that, joining that 2 points, and it joins with the other side, the second lateral side, and at the point of that joining that light ray with the surface of that prism, we have to consider another normal line, that is a normal line to the second surface. Then after obtaining these particular light rays, the incident light rays, now we obtain the refracted light rays by placing the pins. Then after that, we have to consider the internal part or inner part of that glass prism. Then inner part means that is a glass material. Then inside a single medium, the light ray should always move in a straight line. So from the first surface to second surface, the light ray follows a straight line. So we just join in that 2 points on the lateral sides. That indicates the path of that light ray at the interior part of that prism. Then after joining that one, just we have to extend the incident light ray. The path of that incident light ray we are extending, and also we are extending the path of that refracted light ray. Due to the refraction of the prism, the path of that incident light ray changes, and finally, or the emerging section, we obtained a light ray, that is the emergent light ray or the refracted light ray, that undergoes refraction on the 2 surfaces, first lateral side and the second lateral side of that prism. Then finally we obtain it as the emergent light ray. Then due to the refraction, this much bending happens to that light ray. How much bending is taken place for that particular light ray? That we can obtain by extending the path of this incident light ray and the emergent light ray. Then after extending that one, we obtain the point of intersection of these incident light ray and the refracted light ray, which we are extended. And here we obtain a particular angle, that is the angle of deviation or angle of minimum deviation of that prism. Due to the refraction, the incident light ray undergoes a particular amount of bending, and that bending is known as that angle is known as angle of deviation or angle of minimum deviation for a prism, and normally it is represented with the letter D, that is the angle of deviation or angle of minimum deviation. On the front surface or the first surface, the angle between that normal and the incident light ray we can consider it as angle of incidence, and on the emerging section the angle between that emergent light ray and the normal is we can consider as the angle of emergence, and the angle between the extended part of that incident light ray and the extended part of the emergent light ray, that is known as the angle of deviation or angle of minimum deviation. As a result of this refraction, the emergent light ray is always bent towards the base side of that prism. That is one conclusion we can make as a result of this refraction of light ray through the glass prism. The emergent light ray is bent towards the direction of incident light ray, or in other words we can say the emergent light ray is always bent towards the base side of that prism. That is a conclusion we can consider about the emergent light ray related to the refraction of light through a prism. The emergent light ray is always bent towards the direction of incident light ray or towards the base side of that prism. Next, we have to consider another phenomenon, that is dispersion of light. Dispersion of light is an extension of refraction. That means whenever light moves through a transparent medium, it splits up into its 7 component colors. When a white light is passing through a transparent medium, it splits up into its 7 component colors. That phenomenon is known as dispersion of white light. The dispersion of white light is an extension of refraction that we already mentioned. Then why these different colors, why it is splits up into its different colors or component colors? The color of light is a basic phenomenon of the wavelength. Already we mentioned that light is an electromagnetic wave, and each and every wave has the wavelength and frequency. So the color of light means the different light appears in different colors as a result of the variation of wavelength. The wavelength in a particular range appears in a particular color, and in another range appears in another color. That kind of 7 range of wavelength are available for visible light. The color only you have to keep in mind is the color of light means that is due to the wavelength, the variation of wavelength. While taking place the refraction, different amount of variation or different amount of bending is undergone by this different range of wavelength. The visible light means that is a combination of different range of wavelength, and these different range of wavelength are undergoing different amount of bending. That's why as a result of this refraction through this prism, the emergent section appears in the form of different segments or sections, because there's a small range of that wavelength undergoes a small amount of bending, another range of wavelength undergoes another amount of bending, then the other range of wavelength undergoes another amount of wavelength. As a result, on the other side or the emerging side, it appears as a 7 segments or a 7 partitions appears in different colors, and that kind of 7 segment is known as the spectrum of white light. The 7 colored spectrum, that is the mnemonics you already know that is a VIBGYOR. Violet, indigo, blue, green, yellow, orange and red are the 7 component colors of white light, and that 7 segment color is known as the spectrum of visible light. Due to the dispersion, that means different amount of wavelength of light undergoes different amount of bending or different amount of refraction. As a result, we obtain these kind of 7 segment of color or spectrum of light. That is, dispersion means the phenomenon of splitting up of white light into its 7 component colors when it is passing through a transparent medium. Then why this kind of splitting up of white 7 components are happening? That is due to the variation of amount of bending or variation of amount of refraction as a result of variation of wavelength. Different wavelength of light undergoes different amount of bending. That is the reason for this dispersion phenomenon. Okay. And this dispersion phenomenon or this kind of white light is a 7 component combination that is first identified by this Isaac Newton. And you are familiar from the lower class itself, that is the Newton's color disc. That means a circular disc is considered and that is divided into 7 equal segments and painted each segment is painted with 7 colors, and when it is rotating with a particular speed, it appears in a white color. From that we can conclude that the 7 component colors are combined together to form white light. That means white light is composed of 7 colors. And the same thing is again verified with the help of this prism. When a white light or a beam of white light is allowed to pass through a glass prism, then on the other side we obtain this kind of a 7 colored segment or spectrum of white light. And on the other side, in order to verify that one, from white light we obtain 7 colors, and again to verify for the completion of that verification, we have to again what happens, we have to recombine these 7 colors and to obtain white light. Then we can again verify that the white light is a combination of 7 colors. For that purpose, Sir Isaac Newton placed another prism in the inverted manner on the other side and allowed these 7 colors, the 7 segmented colors is allowed to pass through the second prism. Then on the other side, on the emergent section, again we obtain a single beam of white light. That again implies what? White light is allowed to pass through the first prism, then on the emerging section we obtain the 7 segmented color, then that 7 segmented colors is allowed to pass through another prism in an inverted manner, and on the emerging side, on the outer side we obtain what? White light beam. That again verifies that white light is composed of 7 colors. Anyhow, the dispersion means the phenomenon of splitting up of white light into its 7 segment color when it is passing through a transparent medium. And why this dispersion happens? Because different amount of wavelength of light undergoes different amount of bending. Different color, or in a simple words, different color of light undergoes different amount of bending or different amount of refraction. That is the reason for this dispersion phenomenon. Different color of light undergoes different amount of bending. Why these different colors? That is due to the variation of wavelength. Different wavelength appears in different color. Okay. Normally, the visible light, that is the range of electromagnetic energy which we can visible, is almost in a ranging from 480 nanometer to 680 nanometer. That is the range of wavelength, and that is the 7 segment colors range of wavelength. From violet to red, the wavelength is ranging from 480 nanometer to 680 nanometer. Among these 7 colors, the violet color undergoes maximum amount of bending or maximum amount of refraction because it has less wavelength. And among these 7 colors, red color undergoes least amount of bending or minimum amount of bending because the red color has high wavelength. Due to the high wavelength, the red color only undergoes a small amount of bending, and the violet color undergoes maximum amount of bending because its wavelength is very less or very small.